Hey there, I see you. I see you back again. Well, those of you that have been following us in this 2012 journey, this wonderful trip, I see you and welcome back. If you're here for the first time, hey, welcome to you as well. We are going to cover problems, multiple choice problems, numbers 21 through 28, section 1, part A. So sorry we don't get a calculator. This is the practice AP Calculus AB exam that College Board put out in 2012, okay? I did 2 previous videos with problems 1 through 10 and problems 11 through 20. I think this is going to take slightly longer than those. These last group of 8 problems tend to be, some of them can be algebra heavy, okay? But you know what? Let's get started. Before we do, 2 things. Follow me. Following me helps you because you will then get notifications when I post a new video. Okay, so that helps you. And like the video because that helps me. Okay, and when you're down there ringing that bell, ring a ding, 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 dong. In the comments, why don't you drop a little note there if you're thinking you want to see a certain test. I'll do that one next, definitely. Okay, so let's get started. Number 21. Number 21 says, the line y equals 5 is a horizontal asymptote to the graph of which of the following functions? Couple things we need to identify here. First, if y equals 5 is a horizontal asymptote, weird to put that P in front of the T, but it's still one of my favorite mathematical words, asymptote. It's crazy. So to get a horizontal asymptote, the limit as x goes to either positive or negative infinity of our function has to equal the value of our horizontal asymptote, okay, which is 5 in this case. So one of these options, A, B, C, D, or E, should equal 5 when I take the limit as x would go to positive or negative infinity. Now, the second thing we need to know is, well, how do we handle this? How do we handle a function when we take the limit of it as x goes to positive or negative infinity? That is the nature of the problem. Well, if you have a fraction, if you don't have a fraction, you just plug in an infinity and you kind of evaluate, hey, it's either going to go up forever, it's going to go down forever, or it's going to approach 0. Okay? But if we have a fraction, we keep the biggest term on the top and the biggest term on the bottom, so our numerator and denominator, and then we reduce, okay? And maybe the x goes away and we're just left with the value, 5. Or there's an x remaining where I put the infinity in and I evaluate, okay? So as I look at these problems here, I laugh at what they did, not because, it's a joke or anything funny, but the way they try and trick you. There's a 5 in this problem. 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 A, B, C, and D all have a 5 in them. But the answer here is actually E. All right? And let me explain. First of all, I think the limit as x goes to either 0 or 1 for this one would equal 5, not infinity. So it can't be this one. If I put an infinity in for x here, well, 5 times infinity is still infinity, okay? That's not 5. For C, the biggest term on top is 1. The biggest term on the bottom is x, okay? If I plug an infinity in for this x, well, as the bottom of a fraction gets bigger and bigger and bigger, more so than the top, it would eventually approach 0, not 5. Now, a lot of my students, if a student misses this problem, it's because they pick D, not A, B, or C. Okay? And how come? They pick the biggest term on the top, they say, oh, it's 5x. They pick the biggest term on the bottom, they say, oh, that's x. Well, that reduces to 5. Look at us. They just forget that the biggest term on the bottom is negative x, which means this is negative 5, not 5. Okay? And choice E, obviously the biggest term on the top is 20x squared. The biggest term on the bottom, well, that's a positive 4x squared. Our x squareds canceled, and 20 divided by 4 is my 5. So that's how I get choice E, but it's funny that the horizontal asymptote is y equals 5, and every answer that's wrong has a 5 in it. The one answer that's correct does not have a 5 in it at all. Those crazy College Board peeps, they're nuts. When will they ever learn? Number 22. Let f be the function defined by f of x equals the ln of x over x. What is the absolute maximum value of f? Okay, let's break this down. Let's break it down, DJ Lance. If I want to find the absolute maximum value, okay, the first thing I need to do is I need to find critical points. That's where my first derivative is equal to 0, all right? And then those are the only places where we can have possible mins and maxes. In our case, we want a maximum. So I want to make sure wherever my critical point is, I have a positive slope or derivative going up to it, and a negative slope or derivative after it. That would definitely tell me that this is a max. Okay, I have a max point, okay, right there. I don't want to know where my max occurs. I want to know the absolute maximum value. The x is where it occurs, or the location of the max. The y is the actual value. Okay, so I'm going to want that y coordinate when I find the maximum, not the x coordinate. All right? So let's do this. And we'll start with a nice, because it's November 4th, but it's going to be like 71 degrees today, which is very strange for the Finger Lakes region in upstate New York, which is where I'm from. Okay? So let's take a look at this. Orange represent nice fall. And let's take the derivative of our function. Our function is the ln of x over x, all right? That is a fraction, so I'm going to use the quotient rule. The way I do this is it's low times the d high, or the derivative of the numerator, which is 1 over x. That's the derivative of ln of x. So it's low d high minus high, just as it is, ln of x, times d low, the derivative below. The derivative of x is just 1. Okay? I draw a line and I square below, or I square the denominator. Okay? That's my derivative. Let's clean it up a bit. And while the first term here, my x's are going to cancel, I just have 1 minus. 1 times anything is itself, so that's ln of x, over x squared. Okay? This is the first derivative. I want to find out where this is equal to 0. All right? Let's find out where that's equal to 0. So, let's keep on scrolling. Keep on scrolling. Keep on scrolling. All right. In order for a fraction to equal 0, I need 0 over anything. Okay? So I only want to make sure, I want to see where this equals 0. So 1 minus the ln of x equals 0. What value of x does that happen? This is where it helps to know your rules for natural log, or ln. The ln of e is equal to 1. Okay? So 1 minus that, that's where it's 0. Okay? Whenever x equals e. And that's approximately 2.718, etc. It's like pi, goes on forever. It's irrational. That's where my critical point can be. That's where a possible min or max is for us. So let's go to the left side of the screen here, and let's draw a little number line. Little number line. Okay, here's my x value when it's e, or 2.718. And my first derivative, that's where it's 0. That's where I have a first derivative of 0. So that's my possible critical point. Okay, so let's check a value on the left and right and see if the derivative is positive or the slope is positive of f, and or if it's negative. All right, so I'm going to pick numbers. I'll pick 1 because I know my rules for natural log. And then I'm going to pick, I don't know, 5. All right, I can pick any number. All right, and again, I've got to put that into the derivative. The derivative is this thing right here. Now, something nice with our derivative. The denominator is squared. What does that mean? Well, that tells me that no matter what I pick, okay, I'm going to rewrite this right down here. It's the L1 minus the Ln of x over x squared. The bottom will always be positive, no matter if I put a positive value in there or a negative value, okay? So the one thing that's going to dictate to me whether my derivative is positive or negative is the numerator. If the numerator is negative, then I'll have a negative fraction, correct? If the numerator is positive, then I'll have a positive fraction because I'll have positive over positive. It'll be negative if I have negative over positive, all right? So I only need to see the sign of this, okay? I'm going to start with 1, x equals 1. 1 minus the Ln of 1. You should know your rules that the Ln of 1 is actually 0. That's a positive value. So this side is positive. It's increasing up my graph to my critical point. Let's try 5, okay? 1 minus the Ln of 5. Well, I tell you what. As I go further down the number line, okay, if I start at 1 and my Ln of 1 is 0, okay, and then I pick e, which is this value here, and the Ln of e is 1. Okay, so let me write this down quickly. The Ln of 1 was 0. The Ln of e, which was 2.718, that is 1. You see how it is increased? So if I pick any number bigger than e, it will be greater than 1. It has to be bigger than this, because notice it's going up. I go up. It increases. I go up. Okay, e to the x is an increasing function. Okay? So I don't know what number this is. I just know that it's going to be greater than 1. If I take 1 and subtract a number bigger than 1, I don't know, 2, won't it be negative? It sure as poo-poo will. It's negative. So I do have, okay, a maximum point right here. An x value of e is where it happens. Notice that's not even a response. How come? Because they don't want where it occurs. They don't want where it occurs. What they want is the actual value. So now I got to find the y coordinate when x equals e. Okay? When x equals e, that's my x value. What's the y? And I go back to the original equation anytime I want a coordinate. Okay? So the Ln of e over e. All I did was throw in my e for x. I'm not trying to confuse you. E is a number, x is a variable. All right? The Ln of e, we already know that's 1 over, well, I don't have a calculator, so I'm just going to leave this e. This is the max value. 1 over e, that's choice B. That was kind of a lot to take in. If I wasn't explaining it, it would go a lot faster. Okay, but you still need to take your time. All right, and I like to explain things when I can. I don't always, I try to, but you're here either to check your answer or to understand how this problem's done. So hopefully you have a better understanding now how 22 is done. 23. If P of t is the size of a population at time t, which of the following differential equations describes a linear growth in the size of the population? I like this problem because it's easy. I don't like this problem because to me it really doesn't, it's not calculus-y enough, if that makes sense. It's not calculus enough for me. And what do I mean? This is really a lot easier than you think. Normally, when I hear differential equations and I see all these dp's, dt's, I normally think separable differential equations, meaning I get a P on this side with the dP, and I get any T on this side with a dt, and then I integrate them both. But guess what? I don't have to do this at all. Okay? I don't have to do this at all. If P of T equals some population, right, at some time, which one of these? Notice that this is dP dt is the derivative, right? Or sometimes we call it the slope of our function, okay? So which one of those derivatives or slopes, because that's all your answers, would represent linear growth? Linear has a constant slope. Slope doesn't change for a line, does it? Y equals 3x minus 7. That slope is 3 no matter where you are. It doesn't change. It is a constant. If we have a constant slope, that means our derivative should be a constant. And there is only one choice on this whole problem that has a constant by itself as the derivative or the slope, and that's choice A. That's a variable that can change. Variable can change. Variable that can change. Variable that can change. A is the only one. So now that you see how easy that is, you're probably like, oh, thank God that was easy. But I think it's easy enough to where people are going to get confused and might not get this right. Or they might pick 200t because in an equation of a line, you have a constant in front of your variable. I don't know. But very simple. I just would like it more calculus. I would like to do more calculus equations and calculations in it. Not just think of the slope of a line. All right. We have 24 here. Okay, I'm going to do a little bit more algebra because, again, I always say calculus is algebra heavy. Okay, let g be the function given by g of x equals x squared times e to the kx, where k is a constant. Okay, k is a constant. It is not a variable. There's our k right there. Boop. For what value of k does g have a critical point at x equals 2/3? All right, now we've got kind of like a map to follow here. Again, a critical point means the first derivative should be equal to 0, and they want that at an x value of 2/3. So I got to figure out what value of k would make this happen. All right? Well, I think the first thing we need to do is find the derivative. Okay, so let's go ahead and do that. If g of x equals x squared e to the kx, all right, this is a product rule. Okay, it is the first times the derivative of the second. Okay, the derivative of e to anything, you always start by writing itself first, times the derivative of the exponent. Remember, k is a constant, like, I don't know, 9. Wouldn't the derivative of 9x be 9? So if it's kx, wouldn't it just be k? It would be. So it's e to the kx times the derivative of the exponent, which is just k, and I'll put that out front. Okay? First times the derivative of the second plus the second, just as it is, e to the kx times the derivative of the first. The derivative of x squared is 2x. This is the first derivative. Let's rewrite this so it's nice and a little bit more organized. We're going to put kx squared e to the kx, that's the first term, plus 2x e to the kx. All right. We want to figure out where this is equal to 0. Factoring never goes away. I tell this to my Algebra 2 kids. I wish I can go into 7th grade and 8th grade math classrooms, 9th grade math classrooms, and tell them factoring never goes away. I do on occasion. I'm at a high school. Actually, I'm at a school. It's K through 12. And sometimes I go down to middle school. I'll walk in there, and if they're factoring, I tell them, even kids in calculus still factor. All right, let's figure out what is a common factor that I can take out. Well, they both have e to the kx. You can take that out. And they both have at least one x to take out. So that's what I'm going to take out. There. So I'm going to take out 1x and then e to the kx. Okay, when I take that out, I still have a k here. I still have 1x. The rest of that is gone. Plus, I have the 2 here. And everything else comes out. And that equals 0. So let's now solve for this at an x value of 2/3. Because remember, I want to solve for k that would make this 0 under this condition that x is 2/3. Okay, so we have 2/3 e to the k times 2/3. Okay, times k times x, which is still 2/3, plus 2 equals 0. Now we're just going to solve this. And the first thing I'm going to do is I'm going to divide both sides by 2/3 e to the k times 2/3. Okay? And how can I do that? There's no variable here anymore. Remember, k is a constant. Okay? So 2/3 e k 2/3. All right? This goes bye-bye. Anything with a 0 on top is 0. Now this is really easy. This is 2/3 k plus 2. Now we have done all that work and it has paid off. All right? So let's just subtract 2 from both sides. Boom. And I got 2/3 k equals -2. Now I'm just going to multiply by the reciprocal. Bang, bang. Multiply by that same reciprocal, and k equals, my 2's cancel, but I have -3. So a k value of -3 would result in having this function have a critical point when x is 2/3. So my k value should be -3. Number 25 reads, which of the following is the solution to the differential equation dy dx equals 2 sine of x with the initial condition y of pi equals 1? All right, you know, I don't have to do separable differential equations, but I think I'm going to. Yeah, I don't have to. I need to get the original equation. I have the derivative. Okay, if I want the original equation, all I've got to do is integrate. All right, I integrate the derivative. All right, so let's do separable differential equations anyways, because we're going to end up taking the integral of that anyway. So what I'm going to do, I'll multiply both sides by dx. I got dy equals 2 sine of x dx. Now I can integrate both sides. This gives me a y plus c, let's not forget our constant, equals, all right, I'm going to pull this constant out, 2. What do I take the derivative of to get sine? I take the derivative of negative cosine to give me sine. And again, I got to have a plus c over here. Let's call this c1 and c2. All right? Well, we need to get y alone, so let's subtract c1 from both sides. These are constants, so y equals -2 cosine of x. Whenever I combine two constants, I still get a third constant. I could put a 3 here, but at this point, I don't have to. The reason I put the 1 and 2 is because I have 2 constants. I only have 1 now, so I'm just going to leave that c. I don't have an exact equation yet, but I need to get one based on this condition right here. Train your brain to realize that this is really a coordinate. When x is pi, your output is y, which is 1. So y equals 1 at negative 2 cosine of x, which happens to be pi, plus c. Know your trig values. The cosine of pi is negative 1. Okay, so I multiply that times negative 2 plus c, and I get 2 plus c equals my 1. Well, now, this is just a cakewalk now. Let's subtract 2 from both sides. Negative 1 equals c. This value is what has to go right here and for this c. Y equals negative 2 cosine of x minus 1, because that was my c value. That's the solution that satisfies that differential equation under this condition. That is choice E. Choice E. God, I love it when it works out. Nice and fluent. 26 says, let g be a function with first derivative given by g prime of x is the integration from 0 to x of e raised to the negative t squared dt. Which of the following must be true on the interval from 0 to 2? Now, if we look at our answers here, okay, we look at all of our answers. G is increasing, increasing, decreasing, decreasing, decreasing. All right, that tells me I'm definitely going to have to evaluate the first derivative. All right, and then it says concave up, concave down, concave up, concave down, something about a point of inflection, and that tells me I need to evaluate the second derivative. All right, so let's take a look at what we got, and nice of them, oh, look how nice they are. They already gave us the first derivative. So let's take a look at this. The first derivative of g was the integration from 0 to x of e to the negative t squared dt dt. So we have this integration, and if we know anything or remember anything, integration is really just area under the curve. Okay? Why is this important? Because I really need to see if the first derivative is positive or negative. That's going to tell me whether the original function is increasing or decreasing. All right? So if I look at this equation right here, E, all right? If I were to graph, don't know why that happens sometimes, but if I were to graph e to the negative t squared, that's a positive function. It's just decreasing. What do I mean? Anything above the x-axis is considered positive, and anything below the x-axis is considered negative. So if I were to graph this right here, it kind of looks something like this. Remember, we're only evaluating from 0 to 2. Says so right here. Look at that. Okay? So all this area under the curve, that's going to be considered positive because it's above the x-axis. So this is positive, which means if the first derivative is positive, my function should be increasing. This is a possibility. This is a possibility. No, 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 bye-bye. Okay? So now we need to look at the second derivative. Okay, let's go with a nice mint green. That's pretty. Hopefully you can see that well. In order to get the second derivative, I need to take the derivative of the first derivative. And the first derivative is our integral from 0 to x of e to the negative t squared dx. All right? So if I take the first derivative and I take the derivative of that, I also have to take the derivative of this side, which is fantastic because derivatives and integrals cancel. The dummy variable, which should say dt, cancels, and my x just goes in for that t. Didn't we just say this was a positive function? We just said this is a positive function, right? Second derivative is equal to this. So if I graph this from 0 to 2, it's going to be a positive, it's going to have some positive value. All these values, okay, every dot along this line has a positive y value. This is also going to be positive, okay? The second derivative is positive, which means it's concave up. So again, I don't care about this one, or this one, or this one. Concave down, no, bye-bye. Concave up. So we really didn't have to do any sort of calculations. We really just had to understand what the graph of E looks like. Even if it's a negative exponent, okay? That just means it's decreasing. It's still positive, but it's a decreasing positive function. Good deal. 27. If x plus 2y times dy dx equals 2x minus y, what is the value of d2y over dx2? Basically, what's the second derivative at the point where x is 3 and y is 0? All right. This is going to be a two-step problem. Start with the gray. They give us x. Ooh, we went to thin gray. X plus 2y times dy dx equals 2x minus y. Okay? In order to find the second derivative, here, we need to find the first derivative, which means I need to isolate this right here. And there's only one way to do that, by dividing both sides by x plus 2y. So my first derivative equals 2x minus y over x plus 2y. That's the first derivative. They want me to find the second derivative. All right? If I have a fraction, I need to use my quotient rule. The quotient rule, which is low x plus 2y times d high, the derivative of the numerator, is 2 minus, the derivative of y is 1. But every time I take the derivative of y, don't forget, I need to write dy dx. Okay? Low d high minus high, just as it is, or the numerator, just as it is, 2x minus y, times the derivative of below. Okay, the derivative of x is 1, plus the derivative of 2y is 2, dy dx. Okay, all over, okay, draw a line, and I square below. Okay, so I take x plus 2y, and I square it. Okay. I want this at the point where x is 3 and y is 0. X is 3. So wherever there's an x, I'm going to put a 3. Right there, right there, right there. Wherever there's a y, I'm going to put a 0. Love putting in zeros. Everything goes bye-bye. But here's the problem. What do I do for dy dx here? Here's what I do. Dy dx is this thing, but I don't want to put in this whole thing. All right? So why don't I take my x is 3, y is 0. At x is 3, y is 0, and plug those numbers in here and get my number for dy dx, okay? So, anywhere there's an x, we're going to put a 3. Ooh, right there, right here. Anywhere there's a y, we're going to do a 0. Right there, right there. Let's calculate. 2 times 3 minus 0 over 3 plus 2 times 0. Bye-bye, bye-bye. 6 over 3, which equals 2. dy dx at this point is going to equal 2, which means I'm going to put a 2 in for all of my dy dx's right here. 3 goes in for x, 0 goes in for y, and a 2 goes into dy dx. Great. 3 plus 2 times 0 times 2 minus a 2 goes in for dy dx minus 2 times 3 minus 0 times 1 plus 2 times 2 all over 3 plus 2 times 0 squared. That's 3 plus 0, which is 3 times 0. That's 0. Minus 2 times 3 is 6 minus 0, which is 6, times 1 plus 4, which is 5. 6 times 5 is 30, so minus 30 all over. 3 plus 0 is 3 squared. 3 squared is 9. Negative 30 over 9, which reduces to negative 10 thirds. I don't know which way it's written. Well, it's written, it's reduced. Our answer is A, negative 10 thirds. Very algebra heavy, but not difficult. Just take your time. Be patient. You got this. I can't believe we're on the last one already. 28. For t being greater than or equal to 0, the position of a particle moving along the x-axis is given by x of t equals sine of t minus cosine of t. What is the acceleration of the particle at the point where velocity is first equal to 0? All right, let's figure out what they want from us. What is the acceleration? So I'm going to find the acceleration at the points where the velocity is first equal to 0. So this value of time is the same time I want that makes the velocity equal to 0. So I need to look, and they give me position. Okay, that means I need to find velocity, figure out what value of t makes that equal to 0, and then I need to find acceleration and plug that same t into acceleration. Let's go. Velocity is the derivative of position. The derivative of sine is cosine of t minus the derivative of cosine is negative sine of t. Whenever I subtract a negative, it turns to a positive. That's velocity. All right? Acceleration is the derivative of velocity. Okay? The derivative of cosine is negative sine of t plus the derivative of sine is cosine of t. That's acceleration. So now that we have velocity and acceleration, okay, I can't solve for my acceleration yet because I need to know what time to use. The time I use is whatever makes my velocity equal to 0. Okay, so let's do this. Okay, so here we go. This is where knowing trigonometry comes in handy. Now, some people like to use the unit circle. Some people like to use the graphs or special triangles. I think the unit circle has everything on it, but I don't know. I like the visuals of the graphs of sine and cosine in my special triangles, right? In order for the cosine of t plus the sine of t to equal 0, okay? They need to be the same value, but one of them has to be positive and one has to be negative, okay? or this has to be negative and this has to be positive. All right, but they have to be the same value. Just one positive, one negative, and they will cancel out to 0. I know that the sine of 45 is equal to the cosine of 45, which is 1 over radical 2, or you might see it as is it 2 radical 2 over 2? Multiply? Yeah, no, it's canceled. That just seems really weird. I'm just going to say 1 over radical 2. Actually, no, it will just be radical 2 over 2. My bad. You might see it as radical 2 over 2. I always use it this way. I don't simplify it unless I have to. Okay? So they're the same at 45 degrees, but I don't want to just put 1 over radical 2 plus 1 over radical 2. That would end up being 2 over radical 2, not 0. One of those values should be positive and one should be negative. This is where I look at the graphs, okay? And I'm going to show you what I'm talking about right now. Oh, right there. 90, 180, 270, 360. Here's 1, here's -1, here's 0 on the y, and here's 0 for degrees. Cosine, which we'll do in red, starts up here. It's a cup, right? It looks like a cup. Okay, so it kind of comes down, does this cuppy thing, comes up, and it curves. Sine, which I guess we'll do in green, is the S. Starts in the middle and the end is a 0. Comes up high and down low. And it's an S. The sine is the S. The cosine is like the cup. Now, if I know they're the same at 45, which is right here, this is where they're both 1 over radical 2. Okay, I need to look at, I keep on going, doom, right here. Okay, instead of going this way 45, I'm going to go this way 45 degrees. So 90 and 45 is 135 degrees. Okay, you'll notice that one of them is a positive 1 over radical 2 for a y value, and the other one is a negative 1 over radical 2. Okay, so my green curve, which is sine, would be positive 1 over radical 2, and the red curve, which is my cosine, would be negative. When I combine negative 1 over radical 2 plus a positive 1, that's when I get my 0. So that happens at 135 degrees. Okay, so my t needs to be 135, or if you're doing this in radians, which you can, I believe that's 3 pi over 4. Okay? So that's the t value that I want in acceleration. So a of, we'll call it 135 for now, is negative sine of t plus cosine of t. Okay? So it's negative sine of 135, which we just did, plus cosine of 135. Okay, the sine of 135, is right here. It's positive 1 radical 2. I mean, it's right here. Okay, so it is 1 over radical 2, this right here. But don't forget, I still have to negate it. Plus the cosine of 135 is right here, which is negative. I mean, it's right here. We just did it. Okay? So that's negative 1 over radical 2. So we're just going to combine these. This becomes negative 1 over radical 2 plus negative 1 over radical 2, which is negative 2 over radical 2. If I look at my answers, that's not there. Why? Because they simplify it. I only simplify these if I need to, and in this case, I need to. Multiple choice on the test simplifies. The short answers, you really don't have, it never tells you to simplify in the free response questions. But multiple choice questions typically always simplify. So if I have negative 2 over the square root of 2, I multiply the top and bottom by the square root of 2, and I get negative 2 square root of 2 over 2 squared. 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 2. Well, the 2's cancel. And I end up with the negative square root of 2. So my answer, what's the value of acceleration when velocity is equal to 0? Okay? For a position given sine of t minus cosine of t, okay, is the negative square root of 2, which is choice A. Whoo! 45 minutes. That was a longer video. A lot of explaining and a lot of algebra. That was definitely a lot longer than questions 1 through 10. There were 10 questions. And questions 11 through 20. There were also 10 questions. These last bulk of questions generally require a little bit more work. So, hey, like I said earlier, if you want to get notifications when I put up new videos, you follow me. If you, you want to do me a solid, like the video. But also, if you want to see a certain video, put that in the comments and I'll get that done. Otherwise, I'll see you for section 2 where we do get a calculator. All right, see ya.